Morning to all of you. Now today's topic is graph theory. This graph theory topic comes under discrete mathematics. So let's start. So first of all, when we start with the graph theory, you should know that what is graph. Okay. So we can associate this graph with network concept. This network, how you establish. So network, basically you can say that it is a set of node and a set of lines or the set of edges. Network is a graph. Here you can say that this network for the graph is basically a collection of set of nodes as well as set of lines where the set of nodes are connected through the set of lines. You can see 1 2 5 6, all these are the nodes and these are the lines which are connecting them. It's not mandatory that they should be connected. Okay, completely you can see that total part is a graph one. Okay, so now when I say that graph, your mind should be asking why graph one. So when I say the graph, see, graph provides you the different view to study that particular concept, or you can say that graph provides the solution in a much simpler way. Okay, so you can say that it is one of the appropriate tool to solve that problem better way. That's why we are going to graph. So what this network theory or the graph theory provides? It provides various analyzing graphs through which we can understand the pattern. Okay, can understand the agents which are working as a network, and we can apply the graph theory on them and understand them in a better way. Now what is this graph theory, how we move forward? So graph theory is having two components are nodes and edges. So they are made up of components, basic component, nodes, edges. When I say that are the main, okay, we are having the complex systems or this graphs in the day-to-day life system. Okay, like we are having this friendship network, so a graph or network. Again, we have this scientific collaboration network that someone is developing the structure of RNA, doing the study in cell physics or ecology, or creating the agent model intelligence. All these are interconnected somewhere. So these are the nodes points. Okay, so there are some examples with respect of industries, business. One, and take this as a uh, again a one graph. This is genetic network. Okay, how that cells or chromosomes are connected. Or we can take another example with protein to protein interaction network. Okay, so these are again you can say that nodes and edges only, edges or set of lines. This is a transportation network. You can cover, see, can have the various examples. Internet ecological networks are the basic examples. Okay, or one of the important, one of the main examples on which you can apply the graph theory. Okay, so now idea comes that when this idea of this graph theory started. Okay, so you can say that whole idea comes around 1700. So first concept was given by seven bridges. That is, this concept was given by Euler. The concept was seven bridges. So these are the seven bridges. The river. So in a city there are seven bridges. How to size them? How do you cover them? How that minimum distance can be there? So like that. So these are these particular things can be converted to graph, can be called as an edges. That was the initial idea. Then this same extension of the concept was utilized for finding the cycles. Okay, Hamiltonian and Kirkman. So these are the Hamiltonian cycles. So what is a cycle? Basically, complete path, complete, originating from one point at one point, without repeating edges, without, but it is covering all the nodes, covering all the basic idea. Cover this one in front. Now there is another utilized electrical field. In almost you have studied this, Kirchhoff's law, AC and NK. Find out at current and voltage. We are utilizing type of, you can say that we are nodal analysis, and here this graph theory concept is utilized. Okay, chemistry also you can utilize this concept. Now in geography, find out to map the at map to color the map. How many number of minimum number of colors are required so that the two countries are not having the same color. The adjacent what countries are not having. Okay, so this idea was given by these two mathematicians. Now let's move towards the actual concept of the graph theory. As I have told you that graph involves or graph involves the basic entities are vertex or the nodes and the edges, and that main function. Third one is a main function on which vertex and edges are related. So we can say that G is the ordered triple, okay, and G is noted as V and F. What is V? A set of nodes, points, or the vertices, whatever you call it as point, vertices is same thing. Okay, so V is a same point, same thing. Now, what is E? E is group or the set of edges, group or the set of edges, and basically you can say that this is that particular thing. What is F? F is a function which maps each element of edges according to that vertex point, according to that vertex point. Okay, so or whatever we had discussed in the related to vertex and edges, they are mentioned over this basic element. Both are the basic. Vertex is node or the dot or the point, whatever you call, and vertex is denoted as V of G. Vertex of graph G. What is edge? The line connecting two nodes. So we can also call it as a end vertex, end points. एज है एक, उस एज के दो एंड पॉइंट्स होंगे, ठीक है. So an edge is denoted as E of. Now this is one of the example related to this. You can see this graph over here. The numbers 1, 2, 3, 4, 5, 6 are representing the graph value, that is the node. Okay. Now What is edges? Basically, edges are the lines connecting these nodes. So between 1 and 2, I can say that 1 comma 2 is that edge. I can represent that 1 comma 2 as 1 comma 2 or 2 comma 1. Okay, so both will be same provided it is not having the direction. If it is having direction, then I need to specifically write is 1 comma 2 or 2 comma 1. Okay, तो डायरेक्शन रहा तो उसके हिसाब से आपको वैल्यूज को लिखना. नेक्स्ट, हाउ मेनी टाइप ऑफ ग्राफ्स वी हैव? लेट्स डिस्कस दैट थिंग. We have a simple graph. Simple graph is the graph which is without any multiple edges or the self loop. सेल्फ लूप का मतलब क्या है? यहाँ पे कोई एज इस तरीके से ना हो जो खुद से एक सेम पॉइंट से निकल, सेम नोड से निकल के उसी नोड पे वापस आ जाए. ओके, वी विल सी एग्जांपल. और दूसरा चीज क्या नहीं होना चाहिए? मल्टीपल एजेस. सपोज दीज आर दी नोड्स, दो नोड्स के बीच में एक लाइन है, एक एज है, वापस से एक और एज, मल्टीपल एजेस नहीं. So this particular example is a simple graph without any multiple edge or self loop. Okay, you can see this example. This example is having the loop as well as this multiple edge. So it can't be a simple graph. It has to be a that complex one. Multi graph. Now you can see that ये ग्राफ में आपको एरोज नजर आ रहे हैं. दिस एरोज indicates that it is a directed graph, digraph. This concept of digraph you have studied while studying the relations. So this is the idea related to direction. So it is having direction. So when I'm considering this direction, so this becomes the directed graph. So what is an edge? In this case, edge becomes the ordered pair. That is ordering of 1 comma 2 is fixed. 1 comma 2 के बजाय मैं 2 comma 1 नहीं बोल सकता हूँ. तो 1 से ओरिजिनेट होके 2 पे जाएगा और 2 से ओरिजिनेट होके 1 पे नहीं बोलूंगा मैं. तो ये एरो इस तरीके से 1 से 2. So this is an ordered pair from 1 to 2. That is 1 comma 2. I cannot change it. Okay. So that is this new concept. Let's see the next one. What is this? The weighted graph. Weighted means is having some actual weight, positional value. Okay. So this weight is assigned for to all the edges. The edges is having that particular value. So you can see one in between edge 1 and 2. This is 1.2. In edge between 3 to 6. That is 6 to 3. 1.5 weight factor is there. So ये सारे के सारे जो edges है, ये एक example हो गया. ठीक है. Next one is second example, this one. You can see that कुछ जगहों पे edges connected नहीं है. That is nodes are not connected. That is not compulsory कि वो edges वहाँ पे connected ही हो. ठीक है. Now, so sometimes it might be possible कि some nodes are isolated one. Okay, separate. So in this, what type of matrix we are using? So we are using the global matrix for whole graph and local matrix for the single node. Okay, so this might be the case. Now, let's see what is graph structure. To identify the interesting sections of a graph, let's see. They form a significant domain specific structure or because they significantly contribute to graph properties. A subset of the nodes and edges in a graph that possess certain characteristics or relate to each other in a particular graph structure. Okay. What is connectivity under a graph? When I say the connectivity, I can say that how the graph is connected, how the nodes are connected to each other, how you can move from one node to other by following the edges. Okay, and whether two nodes are connected by a path or not, and what is strongly connected. So connected means that it is having at least connection from one node to other. Okay, and what is strongly connected? So if I can say that there is a directed graph from one node to every other node, we will see the example. See this one. So these are the components 1, 2, 3, 4, whatever you say. So I can say that this particular node is connected to all other nodes through some other node. Direct connection na ho chalega, but there is at least some connection. There is some at least some connection. Okay, so that is the case. Okay, now let's see. When I see you, there is another example of the complete graph. I can say, uh, okay. So you can see this is a complete graph. Huh? So all the points, like you take this triangle. This triangle is connected. That all the nodes are connected to each other by direct connection is having. So this node is having a direct connection with all. So in every diagram, whatever you say, whatever the graph you see, that is the direct connection it is having. Okay. So that is a complete graph. When I say that is, it is a strongly connected one. Huh? So that would be called as a strongly connected. And when I am saying that there is at least one connection, one node connection from one point to another point, that is connected. Okay. So let's understand what is the next concept. That concept is called as a degree. Degree. Now, what is degree? It is the number of edges incident on the node. Incident on the node. It might be outgoing or it might be incoming one. Okay, it might be outgoing or it might be incoming one. So you can say that how many lines are coming and outgoing, incoming and outgoing. That is total one. Huh? So that would be the number of edges. That is a degree, total degree, you can say. So you can see that particular example over here. That node 5 is having degree as 3, or you can say that node 4 is having degree as 3. That is 3 edges are there, which is connected to node 4. 6 node is having only one connection. That's why it is degree is 1. That's why the degree is 1. Next we see in a directed graph, it is important that you consider in degree and out degree. What is in degree? The number of edges which are entering to that particular node. And what is out degree? It is the number of edges which are leaving the nodes. So the total degree would be in degree plus out degree. So you can just consider with the previous one. So select this 2, node number 2. So there are two nodes, two edges which are coming inside, and there are two edges which are going outside. Okay. So that is the case. Next one. So how you can find out the degree, total degree? So if my graph is having m number of edges, then I can say that the total degree of that particular vertex, of that particular all the vertex, the total degree, I can say that twice of number of edges. So this m is number of edges, or I can say that m is nothing but cardinality of E. What is E? Is set of edges. Okay, so it is 2 times of cardinality of set E, or number of edges, 2 times number of edges. So since it is 2 times number of edges, 2 times क्या हो जाएगा ये? Permanently even number, you can say. Okay, twice of something. तो ये क्या हो गए? हमारा जो भी डिग्री रहेगा, टोटल डिग्री, that would be always even number. Another concept. If G is a digraph है तो that means that there is a concept of in degree and out degree. So when there is a concept of in degree and out degree, so total in degree should be equal to the out degree. Total in degree should be equal to the out degree, and that is nothing but equal to cardinality of that particular edge. Okay, that is, it is equal to total number of edges. Okay, got the idea? So let's see. Suppose if I start a journey from one node to another node, that journey, okay, it was called as a walk. So a walk of length k, the graph can be called as in a succession of k edges of the form uv, vw, x, like we'll see by the example. So how you denote this walk? Combinedly this total form, 2 से v से w, जैसे 1 से 2 पे पहुंचे, 2 से 3, so this is 1 comma 2, 1 2 3. The total walk will be given as 1 2 2 3, like that. So I can say that this walk is started from u and ending at z. Okay, walk started from u and ended at z. So ये तो हो गया walk. When I can say that walk is a closed one, walk is a closed one, closed or complete one. Hmm. So for that particular part, I could say that if my starting and ending node, if my starting ending node are same, if my starting and ending nodes are same, then I can say that the walk is closed. The walk is closed. The walk is closed. Okay. Now let's see what is a path. A path is a walk. Path is a walk in which all the edges and all the nodes are different. Remember this. All the edges, all the nodes are different. You can consider this one. This is a particular graph. In this, what is walk and what is path? Okay, the walk is, I'm starting the journey from 1 to 2, 2 to 5, 5 to again once again 2 पे, ठीक है, 1 से 2, 2 से 5, 5 से 2, फिर वापस मैंने वहां से 3 पे गया हूँ, 3 से 4. तो दिस इज अ वॉक. वॉक में एजेस रिपीट भी हो सकते हैं, नोट्स भी रिपीट हो सकते हैं, ठीक है. ये हो गया वॉक. एंड हाउ मेनी नोट्स यू आर कवरिंग, दैट इज यू आर कवरिंग, हाउ मेनी एजेस यू आर, total number of edges you are covered, that is the walk of the length. Walk of the length. Okay, so now what is closed walk? What is closed walk? What is closed walk? When I say that closed walk is when I'm starting the journey from point 1 and ending the journey at point 1 only. Is I'm starting the journey from point 1 and ending the journey at point 1 only. So suppose 1 से लेके 1 2 2 से 5 1 से 2 2 से 5 फिर से 2 फिर 3 फिर से 2 पे आया फिर से 1. ये क्या हो गया? दिस इज द क्लोज्ड वॉक. ठीक है. तो जर्नी स्टार्ट की आपने एंड यू आर एंडिंग जर्नी एट सेम पॉइंट. So this is this is the closed walk. Okay. What is path? तो path एक ऐसी चीज है जिसमें नोट्स और एजेस डिफरेंट हो. डिफरेंट मतलब रिपीट ना हो. तो 1 से चालू किया 2 2 से 5 5 से 2 पे आ गए. तो दिस इज नॉट अ पाथ. ठीक है. रिपीटेशन ऑफ द नोट्स और एजेस. सेम एज भी नहीं आना. सेम नोट भी वापस नहीं आना. So in this I'm starting from 1 to 2 2 3 3 to 4 and 4 to 6. The different. So this is the path of length 4. Length 4 कैसे? It is number of edges. Of edges. Now what is cycle? Cycle is a closed walk. There is one extra condition. Cycle is a closed walk which all the edges are different. Which all the edges are. देखो edges के बारे में बोला. Edges different होने चाहिए. But nodes के बारे में कुछ नहीं बोला. ठीक है. तो साइकिल का फंडा क्या है? That is, it is starting from same point and ending at the same point. Same node to same node. So cycle is a closed walk. All the edges are only edges are different. So I can start the journey from 1, end at 1, provided मैंने वापस से पे नहीं आ रहा same edge पे. That is cycle. What are different type of special type of graphs? So I'm having empty graph, or I can say that edgeless graph. Edges ही नहीं है उसमें. No edges are. So only nodes are present. Edges ही नहीं. You can treat this as a simple islands. है कुछ आइलैंड्स है जिसके बीच में कोई डायरेक्ट कनेक्टिविटी नहीं है. तो ये हो गए स्पेशल टाइप ग्राफ, एम्प्टी ग्राफ्स. और आई कैन से दैट नल ग्राफ. कोई नोड ही नहीं है, कोई एजेस ही नहीं. दैट इज नल ग्राफ. ओके. सो देयर आर सम examples. There are some special type of which are trees. Trees. You can say that the trees are connected acyclic graph. There will not be a cyclic. साइकिल कंप्लीट हो जाएगा तो वो ट्री नहीं. एग्जाम्पल देख भाई. आपका रूट होता है तो रूट से फिर ब्रांचेस. तो वापस से जो लीफ है वो रूट पे नहीं आता. दैट इज इट इज नॉट अ कंप्लीट साइकिल. वहां से स्टार्ट हो गए एंड होगा. ठीक है. so that is acyclic. So the same idea is over here. You can see this one. So this is originating at this one. और आप इसको 1 2 3 the another branches. फिर उसके बाद 2 का extension. Next is acyclic. Again, okay. And they can have exactly same path. Okay, between spatial trees. See that can be simple path, can be stars form, but it will be always acyclic. Now, what is regular graph? Regular graph is a well connected graph. Okay, and all the nodes are having the same. So this type of graph is called as the regular graph. You can see this example where every node 1 2 3 5 6, every node is having degree 3. अब देख सकते हो 1 को भी 3 डिग्री, 2 को भी 3 डिग्री, को भी है 4 5 6 सबको सेम डिग्री. Now there are some special regular graphs that are called as cycles. So this is a cycle of degree of order 3, you can say, with the 3 nodes. Cycle with 4 nodes. Every node having this complete. Same with the 5 and 6 one. So now there is next graph, that is bipartite graph. That graph is divided into 2 sets. Huh? So this is the 2 sets of vectors, or that sorry vertex. ये एक वर्टेक्स का सेट हो गया, ये एक वर्टेक्स का सेट है, दोनों के बीच connections, how they are connected. Okay, so there are 2 set of edges, 2 set of vertex. What is complete graph? I already discussed. So here every pair of vertex are adjacent. So हर कोई एक दूसरे का adjacent. One, so there is direct connection between every edges, sorry, every vertex. Okay, so suppose I am considering this point, this red point. So this node is having the connection between this. सकते हो यहाँ से सारे के सारे पॉइंट्स पे कनेक्शन गया हुआ है. तो ये कितने हो गए आपको कंडीशन? हाउ मेनी नंबर ऑफ एजेस वुड बी हैविंग? कितने एजेस होंगे? तो एजेस अगर आपको फाइंड करने हैं तो हाउ अ फॉर्म n into n minus. You can take the consider this square one and you can consider it. So let's find out the number of edges. So how many number of vertex are there? 4 vertex. So 4 into 4 into 4 minus 1, that is 3. 4 into 3, now we get 12 divided by 2. That comes to, you can consider, count 1, 2, 3, 5, 6. So this is true for all the complete graphs. This particular relationship. How many number of edges you can calculate? So in the examination, provided with a question that okay, identify the complete graph, or with 4 vertex, or question might be of the type that identify the path and walk, closed walk. क्वेश्चन कुछ भी तरीके से हो सकता है वहां पे, जो भी कंसेप्ट, किस तरीके का ग्राफ है, स्पेशल ग्राफ है, मल्टी ग्राफ है, ठीक है, एम्प्टी ग्राफ है, तो किस ग्राफ है वो भी पूछा जा सकता है. और कैन बी आस्क्ड दैट यू ड्रॉ एम्प्टी ग्राफ, present an empty. So, or from a particular graph, it can ask you, it can give you multiple path or multiple walk, and it can ask you whether it is cycle, complete walk, closed walk. Okay. Now, what are the planar graphs? Planar graph are the graphs can be drawn on a plane such that no two edges are intersecting. So imagine this particular one. This graph with the 4 nodes. Now see, ये सारे के सारे जो लाइंस, ये कंप्लीट ग्राफ जो है, कंप्लीट ग्राफ, इट इज अ कंप्लीट ग्राफ. कंप्लीट ग्राफ में क्या हो रहा है कि आप देखोगे कि 2 and 4, हाउ यू कनेक्ट दैट 2 and 4. अगर मैं ऊपर डायरेक्टली लाइन खींचता हूँ तो दिस 2 and 4 विल इंटरसेक्ट 1 and 3. तो इंटरसेक्ट नहीं हो रहा है, तो आई कैन ड्रॉ आउटर लूप, और ये इस तरीके से. तो सी दिस, हाँ, दिस K4, प्लेनर ग्राफ ऑफ order 4, inner graph or order 4 is the largest complete graph that can be a planar. ठीक है, तो ये K4 से बड़ा नहीं हो सकता, मतलब 5 पॉइंट्स आप लोगे और उसमें आप सारे के सारे कंप्लीट ग्राफ क्रिएट करो और सारे के सारे पॉइंट्स को आप सोचो कि प्लेनर के फॉर्म में रिप्रेजेंट कर सको, नहीं, दैट इज नॉट पॉसिबल विद ऑर्डर 5 6 7 ऐसे नहीं। अच्छा यहाँ पे देखो 1 2 3 4 5 6, it can be, so this is all the points, all the lines edges are not intersecting, they are separate, so this can be called as a planar graph. Now what is subgraph? What is subgraph? It is having vertex and edge which is are the subset of that complete graph. This is a complete graph, and over here I'm having, over here I'm having this particular subsets, so I can separate I can complete this subset 3 1 2 5. It's 1 2 5 I can separate, that is the next point. Okay, okay, so what are, click, the maximum complete connected subgraphs. So out of a graph, so this, okay, this is a complete graph, maximum complete graph from this one. Okay, what is spanning subgraph? Spanning means distance, the maximum distance covered from one point to another, that is one vertex to the another one. So it is not mandatory that all the edges are considered one. Okay, so I can say that subgraph H to G, so one vertex is one node to the another one, that is a total spanning allow. Okay, again the type of graph under the, okay, so see, I can consider this graph, and from this graph I can draw the spanning tree like this one. And what is this spanning tree? It includes the every node, and it also becomes a tree. Every node also becomes a spanning tree, that is also a tree, so it becomes a spanning. So 0.6 say 0.1 select 0.6 covering the all the points, every node. Okay, spanning. What is isomorphic? Isomorphic का मतलब क्या होता है कि repeated, sorry, that is similar one, two graphs mapping, bijection, one to one mapping is, okay, and it is exactly same, 2 grams are, so similar one you can, okay, so from one particular graph the other graph can be connected exactly, that would be isomorphic. Okay, so isomorphic is when I'm see when I'm considering, hmm, so determining whether two graphs are isomorphic or not, so I can see when you are going to determine, you need to consider that for a particular point, for a particular point or node, the number of edges should be same. Okay, number of edges should be same. So can I say that this graph, the left hand side graph, is equal to the right hand side graph? Let's see. If I consider this point A and point 1, so I am finding the edges. This is the point A, that is the edge, sorry, the vertex point A. So A is having 3 degree, and when one is having the same number of degree, same for the other one also. So if I can relate every node with the every other node, okay, without any dissimilarities, then that would be called as the isomorphic. This is isomorphic problem. Okay, a graph can be represented in a matrix format also. You must have studied that relation form. Okay, the previous sessions you must have seen that relation part, where a relation can be represented in a matrix form. A relation can be represented in a digraph form. So if a relation can be represented in a digraph form, and a relation can also be represented in a matrix, then obviously it can be called कि एक डायग्राफ एक मैट्रिक्स के फॉर्म में रिलेट हो सकता है. ठीक है, किस तरीके के मैट्रिक्स बनेंगे? इंसिडेंट मैट्रिक्स. इट कंटेन्स द वर्टेक्स एंड एजेस. इंसिडेंस मैट्रिक्स, इट कंटेन्स द ऑल द एजेस डेटा. इसमें सारे वर्टेक्स और एजेस के ही डेटा हो. अब व्हाट इज एडजेसेंट डेटा? एडजेसेंट मैट्रिक्स, it is with vertex to vertex or edge weights are there, vertex to vertex. Okay, or so incidence is vertex to edge and adjacent is vertex to vertex. See this one. This is matrix representation of this particular graph. So you can see that यहाँ पे 1 2 5 6 क्या represent are the nodes. What is this 1 2 1 5 and all this? These are representing, so 1 vertex 1 and edge 1 comma 2. That 1 comma 5 is present. 5 is that from vertex 1 we have 2 comma 3 direct connection. तो बाकी सब के लिए 1 comma 2 कनेक्शन, 1 कनेक्टेड है 2 से. Same goes with the vertex to vertex also. 1 2 3 4 5 6, 1 2 3 4 5 6. This vertex to vertex arrangement, adjacent one. 1 comma 1 to have connection between 1 comma 1. There is a loop or not? Loop ही नहीं, सेल्फ लूप नहीं है. अगर सेल्फ लूप होता तो यहाँ पे 1 आता. Okay, so this would be, so this is particular one. Next, this is vertex to vertex. Now with this particular part can create representations, various representation edge list we can create, or adjacent list we can see that edge and node list are created by this one. See, if I'm creating the list, so how you list out all the edges? So it is having the two edges from 1 and 2. So 1 comma 2 1 comma 2, like this all the edges are noted down. Similarly for node list, say this 1 to 2, that is repeated twice, is repeated twice. Okay. One case. Similarly, node list can be now that edge list or the weight can be created based on this. Somewhere that this can be included in the or not in the, that need you need to decide. You can refer that particular out of this service or not. Under the graph theory, to have one idea, one concept, which we can say that it is based on the distance, how much distance you are covering. And it is under the tree part only. Spatial type of graph, tree, spatial concept. How you find out the shortest path. So that is minimum path connecting the two nodes. With the number of edges, find out the number of nodes and all that, and shortest path find out the distance covered between. Okay, so let's see some examples. Can I say that node V and W are adjacent? Node V and W are at each other. They are connected. Are adjacent. They are connected particular points so that they are adjacent. Whether V and X are adjacent, no, there is no direct connection, that cannot be adjacent. What is node U? Node U is incident with edge 2. Node V, so node U. Node U is incident with edge 2. नोड U पे edge 2 connected है क्या? It is connected. So yes, it is true. Edge 5 is incident with node X. देखते भाई, edge 5 वहां पे, X कहाँ पे है? यहाँ पे. Edge 5 और X का कोई रिलेशन नहीं है. This statement is false. The D statement is. Are the two following graphs are isomorphic or not? So अगर isomorphic check करना है तो किस तरीके से check करेंगे? I need to consider that every node, if I can replicate the left hand side graph, the right hand side graph, तो मुझे क्या करना पड़ेगा? First of all, I need to find out how many 3-degree nodes are there, how many 4-degree nodes are there, how many 5-degree nodes are there. So similarly, I need to consider all of them, and उसके हिसाब से मुझे find out करना रहेगा. And if it is matching, then only I can say that it is the, I can replicate them. Okay. How you write down this, how you solve this type of question also? Write down the degree sequence of each of the following graphs. Is having a degree 1, 4, 1, 1, 1, 4. तो अगर मैं कंसिडर करता हूँ, एक सेम यहाँ भी मैं फाइंड आउट की डिग्री Okay, you must have considered this one. Okay, let's see. So complete the following statement concerning the graph. These are the work. Now you need to consider whether it is a walk, whether it is a cycle. So starting from x to y, definitely this is a walk, closed walk, not a cycle. Walk of length. How much length is there? So x to y जाना है 5, and between x to y. Similarly, you can find out the distance for all the non-isomorphic, non-iso same name. It's draw the graph given following. So you can find out the nodes, edges, and adjacent. You can refer this one. Okay. Now you can find out box of length 2 matrix. Let's see the next one. Some other cases. So idea was basically that idea. Okay. Cycle was Euler cycle already have at Euler of vertex. For Euler graph. What is a Euler graph? A graph is a Euler graph. It has Euler cycle. A cycle. So if and only if is connected and all its vertex have even degree, all its vertex have even degree, then only it will be called as Euler graph. And the connected graph then only represents that Konigsberg bridge problem. So the graph which is shown on this left hand side, it is not an Euler graph. Okay. So if it is not an Euler graph, then it is not having a particular solution. Now, what is sum of degree of the graph? This concept we have already seen. Okay. What is Hamiltonian cycle? See, I have told that Hamiltonian cycle we are going to consider. So this is consider the traveling salesman problem. Traveling salesman problem is to visit every vertex or every node only once by a simple cycle. So हर नोड पे जाना है लेकिन एक ही बार. Such a cycle is called as a Hamiltonian cycle. So if a connected graph is there, is a Hamiltonian cycle, then that graph would be called as the Hamiltonian graph. तो यहाँ पे आप बोल सकते हो कि यहाँ पे नोड्स अगर कोई भी पाथ कंसिडर करोगे, नोड्स बार बार एजेस रिपीट हो रहे. साइकिल फॉर्म में नहीं है। यहाँ पे ये सी पॉइंट वापस से रिपीट, ठीक है। स्टार्ट द जर्नी शुड बी अ साइकिल बट विदाउट रिपीटेशन ऑफ वर्टेक्स। That would all about the graph theory under the discrete mathematics. Was all about graph theory. It's discrete. Thank you.